And I didn't get this changed to Keynote today, so I'm just on PowerPoint. Okay, so perimeter was total distance around a polygon. We measure it in linear units. If you don't know what I mean by linear units, I'm meaning just like inches, centimeters, feet, yards, just not a square unit, just a linear straight measure. Okay, then area. What are we finding when we find area? How do you describe that? Okay. How much is inside it? Is it three-dimensional or two-dimensional? It's just two-dimensional. It's a flat. So I described it as the region covered by a shape, and we measure it in square units. Square centimeters, square millimeters, that would be really tiny. Square inches, square feet, square yards. And why do we use squares? Why don't we use hexagonal inches? And why were squares used? What would happen if you tried to put hexagons together?
The squares fit better
Yeah, the squares fit much better together, so it's a lot easier to use those kind of units. Okay, those tangrams. Do any of you still have some of my tangrams? Okay, I'm not sure that I got them all back yet. But that was the puzzle made from a square. If you could get the 7-piece square put together, like was up on top of the page, that's where a tangram comes from. Now the reason that I've got this in here is just to talk about area. We can find the area of the square if we know the area of every separate tangram piece. Because when you put it together, you don't have pieces that are overlapping, and you don't leave gaps if you're trying to make the square out of them. So that's kind of an illustration for the area addition postulate that is in your notes there. The area addition postulate just says that the area of any region is equal to the sum of the areas of its non-overlapping parts. So if you want to find the area of this complete square that the tangram is forming, if you knew the area of the triangle, the little triangle, the medium triangle, another little one, the square and the parallelogram, add it all together and you get the area of the whole thing. How do we use that? We would do something like find the area of this figure. And this is one I want you to do as an example for your area addition postulate. Find the area of this figure. Divide it into regions that don't overlap, but you can also find the area of easily. So split it into something you can find the area of easily, find the area of each of those, and add it together. How are you thinking of dividing it up? So it sounds like you would be splitting it like right here, going vertically. Okay, that could work. Anyone go horizontally across this way? No one did that? You could go that way, or you could do both and make 3 regions. If you really wanted to make a bunch of triangles, you could, but it sounds like a lot of you are doing what Zach did. So what's our area? This one was 20 times 18. That was 360, right? And then 15 times 7 was 105. So when you add it together, your area is 465. What kind of units? Square inches. Okay. I know you write it often inches with the square after it, but can you understand why you would say it's square inches? That really is telling you what size the shape is. It's a square inch. And let's see, sometimes we use tick marks, like if I would go inches, inches, inches. But when you try and label a square, if you go inches squared, that looks like to the 112th power. At least it could look like that. So you don't use the tick marks when you are squaring it. Go back to either inches with the exponent of 2, or probably way back. Remember doing square inches like that? You can write it that way also. All right, so 465 square inches. That was an example of what postulate? Area addition postulate. And you'll use that postulate really without naming it a lot. Okay, I noticed that a few things got kind of blurry when I looked at my presentation here. I don't know why. Okay, I'll talk about what those say. But, okay, I think I put rectangle on your notes, but I didn't really include much of that because it was on your worksheet. So there's rectangle and square, but parallelogram is one that we didn't talk about in chapter 1. So reviewing or talking about the area of a parallelogram, what's kind of blurry right there is if you take a parallelogram, and we already know how to find the area of a rectangle. Does this look about right? If I would cut off at a right angle this end of my parallelogram, this part, cut it off and move it over, it would fit right in here because your angle is the same on parallelogram. So if you slide it over there, then you would create what shape? A rectangle. How do you find the area of a rectangle? Base times height. So this measurement is base, and this perpendicular is the height. Now think about moving it back. When I move it back, I'm creating a parallelogram. Did I change the area of the pieces? No, I didn't trim off anything and throw it away. I've got the same. So to find the area of a parallelogram, we could take base times height. Is the height the slant? No, when I had the rectangle, wasn't that height the perpendicular? Lots of times we label that inside in the parallelogram, just kind of dashing it. Parallelogram and rectangle have the same area formula. They're both base times height. You need to be careful on the parallelogram that you are using the perpendicular height, not the slanted height. So parallelogram area was base times height. And then I put the reminders for the area of a rectangle as base times height and the area of a square as side squared. And I think we'll do an example here on the next screen as far as the area of a parallelogram. And you might also, in your parallelogram picture, you might dash that the height would sometimes be out to the side. It might be from this tip down. Sometimes they dash it out over here. Various places we could show the height on a parallelogram. And if we want the parallelogram to go the other way, you don't have to have the base as being parallel, or I mean being horizontal. Couldn't I do this? Here's my base. Here's my height. If you want a different look to it, you might draw a picture of something like that. Okay, and I'm mentioning that. Oh, perimeters. There are a lot of perimeter formulas. I really don't include all those because too many formulas gets a little confusing. If you just know what perimeter is, that it's the total distance going around a shape, you can always add and find the perimeter. Maybe you'll have to find out some measurements. Maybe you know that some are the same, like in a parallelogram or rectangle, opposite sides are the same. That just makes it easier to know what to add up. But I just simply want you to remember perimeter, you just add up all the sides. All right, let's practice. You need a sample for a parallelogram. Here's a sample. Find the area of this parallelogram. Notice what measurements, the 22 is not that whole bottom. The 22 is from the dashing to the right. The 8 inches is that other little part. What are the correct measurements? Calculate the area. Show yourself the steps so that you can calculate it right. Did I get all the tests and quizzes? Did you have to take them in? What was the base on this problem? 30, correct, and the 8 and the 22 together. And what was the height? 17 or the 15? 15, correct. So just 30 times 15, 450 square inches. Question on that one? If not, here's a little different looking parallelogram. Again, find the area of that long skinny parallelogram. Look at the measurements and see what's what. What can you use for the base and what for the height? The base is always going to be a side of the parallelogram. Could you use the bottom? Well, you might look and see, do I have a perpendicular to the other side? Or could I use the top as the base? Do I have a perpendicular from it to the other side? Or like I drew on the board, do you want to use the slanted one as the base because you've got a perpendicular height? What can we use? You do have to find something. Connor, which way would you do it?
Couldn't you use the 34 and the 30 to like, do the Pythagorean theorem backwards and find the height?
And find the height, so, okay, this is where I wish I could write today on it, but I didn't get it switched. Okay, so this vertical is what you're gonna use for the height. So you're gonna use either this for the base or this one for the base. So 11's gonna be his base, but he figured out he needs to find this for the height. And he said 34. I'm going to move in your mind the 34 over here. Hypotenuse is 34. One leg is 30. He's trying to find the other leg. Got his thinking in mind? Okay, so Pythagorean theorem, let's try and find that height. This is why we did that little bell ringer. Remember how to do that? How much? 16. Correct. Okay, then that was going to be Connor's height. What was his base going to be? 11. Do we have to add the 30 onto it? No. 11 is the side of the parallelogram. The 30 is not a side of the parallelogram. It's just how far out you have to go to get it to be a 90 for the height. So 11 times 16, 176. Explain how you think about that one. Need some more help? Make sense? That one make sense, Andrew? And you can always turn the picture in your book or put measurements over other directions. Maybe you want to put the perpendicular on the right. So feel free to, on your paper, add measurements to line up if you want to look a little bit different. Okay, let's try one that doesn't have a picture. And this one you are trying to find the base of the parallelogram. You're not finding the area. I'm telling you the area. And I'm telling you the height. I want you to find the base. Let's make a picture if you want to. Make sure you make a photo. For all the problems where going backwards, I'm gonna say the same thing, start with the correct formula. I know this one's not a difficult formula to solve, but when we get to the formulas with 1/2 in them, we seem to goof up more often, so if you get in the habit, it'll help you later on. So the correct formula is area is base times height. We know A is 28, H is 56. What are we gonna divide by to solve? Divide by the 28 or the 56? 56. So it ends up a half. The unit was yards, so half of a yard. Okay, let's go to the next shape. Triangles and trapezoids. Triangles should be a review. Okay, so do you need a rectangle and a square example? That's in your notes. I didn't plan one, so if you want to do, be sure you're doing the correct shape. On the bottom of that page were rectangle and square, but I didn't do a separate example. So to be with me, flip the page to triangles and trapezoids. Triangle is 1/2 base times height. You did some of those on your worksheet today, but I think they're worth doing some more review of. Trapezoid has 2 bases. Remember the bases were the parallel sides? They're different lengths. So what we end up doing on a trapezoid is adding the 2 bases and then multiply by the perpendicular height and take half of that total. And I'll show you on the board here how you get that. It really applies to both shapes, triangle or trapezoid. We didn't just make up on a triangle that it's 1/2 base times height. Here's the idea to get that formula. If you take a second copy of that same triangle and flip it over, 2 copies of the same triangle, hopefully those look about the same, you create basically parallelogram. The triangle's only half of it. Well, a parallelogram we just went up through is base times perpendicular height. So for the whole parallelogram, it's base times height. If I'm interested in the triangle, I only want half of it. So either divide it by 2 or multiply by 1/2. That's how we get the triangle. Trapezoid, kind of the same thing. There's one trapezoid, take a copy of it, flip it over, if I can make it look about right. 2 copies of the same triangle, makes a parallelogram, same trapezoid, makes a parallelogram. What's the base of this trapezoid? Well, according to what we labeled to start with, B1, B2, put the height in here. When I flipped it over, this is B1, and this is B2, and this is still the height. So trapezoid is half of the parallelogram. Parallelogram would be the total base times the height, but the trapezoid's only half of that. So either divide it by 2 or take it times 1/2. So that's where the formulas come from. You're interested in using them, so find the area of this triangle. Right triangles are going to be the easiest triangles to find the area of because your base and your height are the 2 legs. And we find that missing base. What are you doing to find the missing base? All right. Pythagorean theorem. Sometime we're going to have to use the trig ratios. Sometime it's going to be a 30, 60, 90. Sometimes it's going to be a 45, 45, 90. So all those things that we've done with right triangles, there's an opportunity that you'll use those at times. Okay, what was the missing base here? 16? Okay. So then area was 1/2 of 16 times 12. You don't distribute and take half of each one. Let's just multiply them together. Half of 16 is 8 times 12 is 96. Or you can multiply 16 and 12 and then take half of it. All right, there's one right triangle example. How about another right triangle? Our special 30, 60, 90. You can probably see those off the wall after today. Force you to learn them. So which side did I give you? Hypotenuse. What's the pattern for the hypotenuse? How many times the short leg? 2. So if 28 is twice the short leg is 14. What's the long leg? Don't give me a decimal. What's the long leg? 14 times the square root of 3. And then find the area. So how do you take 1/2 of 14 square roots of 3 times 14? Probably depends if we want to round it in decimal or if we want exact. If you want exact, don't grab a calculator at all. I think you can really do it without pretty much. So the idea, if you're keeping it in square roots of 3, 1/2 of 14 is 7. 7 times 14 is 98. So 98 times the square root of 3 would be written in radicals. 98 times the square root of 3. If it's telling us that we can round it to decimal, then the calculator is probably helpful. But notice the directions didn't say like round it to the nearest tenth or anything. So it's implying they want the exact area. This is exact. I know it doesn't seem like it is, but that's more exact than a decimal. All right, how about the area of a trapezoid? Trapezoid. Got 2 different bases. Add the bases. Actually, you kind of average the bases. You're adding them and dividing by 2. Isn't that how we found a mid-segment? Add the bases and divide by 2. So we're really doing the mid-segment times the height. So order of operations correct. Be sure you get your parentheses in there. Trapezoid now. 8 plus 5 times 6.2. Half of that total. Sure, I can write it out here so you can see what's going on. Everyone ready? Okay, area. What'd you get?
For the area, 23.5. No,
Check to see, you add, put parentheses, excuse me. Just grabbing it out of your hand. Add that first, and then multiply. So 13 times 6.2, and then half of that. All right, here's a trapezoid picture. You're trying to find a missing base. What did I say I'm always going to tell you to do when you're going backwards? Start with the formula. So write down the appropriate formula for area of a trapezoid. Whatever version you're going to like. If you like the divide by 2 or if you like the 1/2. I like the 1/2 formula. Then start filling in what you know from the information. Put that it equals capital A, so you can fill in A, area is 231. Base 1 looks like it's 23. Base 2 we don't know, 11's the height. How are you going to solve it? And there's more than one way. You need to get rid of everything so that it's just down to the B2. Give me an idea. Lucas, what would you start with, or what do you want me to start with? In solving it. Did you write it with the 1/2 or the divide by 2? Okay, like what's up there? Okay, give me an idea as far as solving it. This 23B? No, because 23B2 means you're multiplying, but we need to add. Okay, so no, not that. That parentheses is going to have to kind of wait till the end. You could probably either distribute 11 or distribute the 1/2, or you can do some dividing to get rid of them. I know what I would probably do. I would probably simplify. In my mind, it doesn't really matter if the times 11 is out there or if I brought it in here. I would probably multiply 1/2 times 11, but that's just me. If I would do that, I would get 5.5 times 23 plus B2 equals 231. I would probably not distribute. I would probably divide by the 5.5 to get rid of it. That then gives me 23 plus B2, help me out, what's 231 divided by 5.5? Is it 11? 19? I don't think that's right. 231 divided by 5.5? 42? Then subtract 23. Is this where the 19 is? So the second base, that's what B2 means, the second base is 19. And we've got millimeters, so we can label our answer. Would you like me to solve it in different steps? No? Because some students like to multiply each side by 2 to get rid of the fraction 1/2, and that would be another way that we could work through it. Okay, rhombus and kite, two shapes that you're probably not as familiar finding the area of. Now a rhombus could be treated like a parallelogram, where we just do base times height, but often on a rhombus and a kite, they'll give you the diagonal lengths, and you can find the area based on the diagonal lengths. So let me try and make this look like a rhombus. Is that close? Diagonal. Diagonal. What's special about the diagonals in a rhombus or a kite? It's just going to be stretched out here more. Okay, so let's think back to that chapter. There are some properties about the diagonals in those shapes. Are they congruent? Two diagonals the same length?
No.
No? Are they cut in half? There's some. One is on a kite. This diagonal is cut in half. This is a kind of parallelogram. So it is bisected. All parallelograms have diagonals that bisect. What's another thing? Are they perpendicular? Yeah, both of them. Diagonals are perpendicular in a kite They are also perpendicular in a rhombus. There's one shape I could probably add to this, a square. Diagonals are also perpendicular there. Okay, well, that is really the category. If the diagonals are perpendicular, you can use this next formula for any four-sided figure where the diagonals are perpendicular. Okay, and how do we come up with it? I'm going to wait to show it to you. Think about putting a big rectangle around either the rhombus or the kite. Now, obviously, that's going to be more area than what we had. But you could find the length and width of that diagonal related to the kite and the rhombus. How wide is this? It's the same as the diameter, or the diagonal there. So this is like the first diagonal's length. How about the height of it? The other diagonal is the height. So the whole big red rectangle would be diagonal 1 times diagonal 2 to find its area. But the kite's not that whole thing, right? The kite, if you look section by section, isn't it half of that big red rectangle? So half of this is the area of the kite. Or you could write it 1/2 diagonal 1 times diagonal 2. Rhombus, same thing. First diagonal, second diagonal, multiply. But the rhombus is only half of it. Well, those two have the same formula. You could use this formula for a square if you really want to. But the area of a rhombus or a kite with diagonals D1 and D2 is A equals 1/2 D1 times D2. If you don't know the length of the diagonals, remember us doing Pythagorean theorem to find some missing measurements? So we probably will have to bring that Pythagorean theorem in again to find some measurements. If they don't give you the diagonals on the rhombus, you could treat it like a parallelogram where you were doing just base times height. And if you get stuck on something, divide it into triangles. Find the area of every triangle. Add it up. That would be a way to do it without just having to leave the blank because you can't remember this formula. All right, let's do an example. Here's a kite to find the area of. I've given you sides of 29 inches and 35 inches. So if it's a kite, what's this top side? 29, and the one over to the right, 35. You might want to write those in. You need to figure out the lengths of the diagonals. So I didn't give you just an easy one. You have to find some missing things. Draw in your perpendiculars at the center. Draw in the diagonals and put the perpendicular markings. That will show you there are right triangles. I'm going to go on the board here so I can do some drawing. Diagonals are perpendicular. If this part was 28 inches, is the other part 28? Look at where your side measurements are. Notice it wouldn't fold to make 28 and 28. What measurement can you figure out? See a right triangle where you have two sides?
Yeah.
Yeah? Bottom one with the Y in it?
Well, the top one too. Not top as in top, no. No, yes, yes.
So if we find Y, we'll also know this part. All right, so work on one of these right triangles. 28's one leg, y is the other leg, 35 is the hypotenuse. I need to know what y is. Good old Pythagorean theorem. 18. So this is 18. So what's that whole diagonal? I'll call it diagonal 1. What's the first diagonal total? 18 and 18 is 36. Yes.
I got one.
21. Am I getting the wrong answer? Is 21, okay.
I got 21 as well.
Try it again, remember, see what you did wrong. Okay, so my diagonal is 42 total. All right, now let's see if we can find x. Okay, got another right triangle here. X is a leg, 21 is the other leg, 29 is the hypotenuse. Are you sure? So how long is the second diagonal? 48 total. Okay, all that works so that now we can find the area, because it asked us to find the area. So area is 1/2 of the product of the diagonals. So 1/2 of 42 times 48.
Is 1,008
1008. And how would I label my units?
inches squared.
108 square inches. Make sure that you guys gave me the right numbers. That's right. Okay. Question, could you do that thinking on your own? We have to go back to some thoughts in that last chapter about quadrilaterals. Okay, find the second diagonal of this kite. Start with the appropriate formula. I'm telling you the area, and there's a kite involved. So write down the area formula for a kite. Let's have a look to see, they are on the wall. There's still a formula or two we haven't done, but trapezoid, kite, square, rectangle, parallelogram, and triangle are there on the wall.
You have a concern?
Start with the correct formula. Fill in what we know. Area is 238. First diagonal is 14. Yeah, I would probably multiply 1/2 times 14 and get 7. Get your area filled in there. So 238 equals 7d2. Back to 7. The second diagonal is question on that one. Okay, there were a couple kites. Here's a rhombus. Find the area of the rhombus with side lengths, not diagonals, side lengths of 15 and one diagonal is 24. I don't know if that's the long diagonal or short diagonal. So we'll just have to put it in one of them and just see what happens. So, how are we going to find its total area? We need the other diagonal. Already reminded ourselves, diagonals are perpendicular. All the sides are the same, 15, 15, 15, 15. One diagonal is 24. And if we put both diagonals in, maybe we want a 12 right in our picture. 12, 12. How do we find the other diagonal? Pythagorean theorem. Another triple. The Pythagorean triple come to mind for anybody? If you don't have a thought on the Pythagorean triple, do that Pythagorean theorem. What do you come up with? And they're not always Pythagorean triples, but I mean this one was. It was a 9. So multiple of a 3, 4, 5. Alright, so 9 was this missing piece. Same triangle over here. So our second diagonal is 18 in the area. 1/2 of 24 times 18. The area is 216 square meters. Question on that one? Okay. Find the second diagonal of this rhombus, and I think we'll end on this one and then get started on our worksheet, unless I forgot something, but I think there's different areas. Okay, so find the second diagonal of this rhombus. I'm telling you the first diagonal is 3 meters. The total area is 12 square meters. Start with the appropriate formula. No, it's not 3 on both sides, it's a total of 3. Total is 3. Did you subtract 1.5 from 12? Subtract. So I'm saying that you should subtract this because it's multiplied. 1.5 times D2. So you should divide. That's not what I'm arguing about. What I'm saying is you've got this right now. 12 equals 1.5 D2. I'm saying since this is multiplied, you should divide by 1. Well, the answer should be 18. No, 8. Did I hear you say 18 earlier? Question on that one? Okay, I'm just going to click, make sure I didn't forget. We did some converting. Well, I'm hinting at your worksheet. What is 1 square yard equal to 1 square inch?
3. 12.
Draw yourself a square yard or a representation of a square yard. Square yard.
72. Gotta be 72. Square root of 72.
Where are you getting 72?
Yeah. It's gotta be 8 points off.
Now, if we have a square If we have a square that's 1 yard by 1 yard, in terms of inches, how many inches wide is that if it's 1 yard? 1 yard's how many inches? Do we not know yards and inches? 1 yard is 3 feet. Each foot is 12 inches. 36. 36 inches wide, 36 inches tall. So wouldn't that be 36 times 36, 1296? Is that right? 1,296? If we have a mile square, so a section out in the country, how many feet, square feet would that be? How many feet in one just straight mile? Good, 5,280. Times another 5,280 to go the other way.
27,878,400.
That's why I put such a big one. So when we're doing square units, we've got to think both directions.
Wait,
as
so
an area. That's how many square feet in a mile section. Like if you had squares that were 1 foot by 1 foot, that's how many of them you need to cover. Seems like a lot, doesn't it? When they drive that tractor and they have to harvest that whole section, that's how many square feet they have to go over, cutting the stalks off. That's a lot. Okay, that worksheet is your assignment. Did I get it handed out to everybody? Be sure you're showing work on your formulas, what numbers you're plugging in, how you're finding missing things. So you don't have to drag your book home. You can just use this worksheet.
I'm sorry, I have a question. Okay, so coming today.
Yep, come in today.
Okay.
Plan to
If
come in
I
Monday.
don't have my test done by Monday,
Were you gonna do like tutoring Monday
Yeah.
or something?
If
We,
you
I
want.
mean, I'll make arrangements with that,
Like,
but
if you keep it at 0, will you, like, put it on the still?
on Monday, yeah, would there be a reason I shouldn't? Are you involved in an activity right
Well,
now next week? I think there was a lot for next week. So I thought I could put it in as a 0 right now and just make sure that
okay, what is, like, we are practice?
you can go to practices, just if there were a game or a performance. Yeah, I didn't think it mattered.
Okay. Yeah,
Oh, yep. Yep, come in and I can talk to you about some things and hopefully get kind of caught up.
Yep.